Question 16, related to electromagnetic effect, the diagram and the photograph shows a moving coil loudspeaker. So the loudspeaker uses the same concept that when a current is passing through a wire, it experiences a force. And as the direction of the current changes, the direction of the force will also change, which causes a vibration of this membrane of the speaker, and that produces a sound. So the diagram, the loudspeaker contain a coil connected to a cone, as you can see here, which is free to move. The coil is in a radial magnetic field. As you can see, this wire is there in a radial magnetic field. And there's a varying current in the coil. The current is continuously changing. The magnetic force is also varying, and this varying force causes the coil and the cone to vibrate and producing a sound. That's how the sound is produced. The diagram below shows a magnet and the coil in the magnetic field. So you can see this is a wire and this is a magnetic field. Explain why, even though the wire is not straight, the force on a single turn of a coil is calculated by using a formula F is equals to BIL. So F is equals to BIL. Actually, it is what the formula to find the force on the wire. That is F is equals to BIL sine theta. And when theta is 90, we can also say F is equals to BIL. So they're saying, let's say we have a magnet and the wire is there, which is 90 degree to the magnetic field. We use this formula F is equals to BIL. We ignore the angle because it is 90. Sine 90 is 1 when the wire is straight. But now they're saying why, even though we have a circular wire, but we are using the same formula. So what is the reason for that? The reason is when we take the small section of this wire, the magnetic field and that section of a wire is perpendicular to each other. Like as if I zoom into the figure, so that small section is actually 90 degree or perpendicular when there's a current is passing. So see, this section is 90 degree. This section is 90 degree. This section is also. So the small section of the wire are perpendicular to the magnetic field. That's why for each section which is 90 degrees, so we use a formula F is equals to BIL instead of using a formula F is equals to BIL sine theta. So magnetic field is always perpendicular to the wire in this case, because there are small section or small section of the coil are there, and for that part it is almost 90 degree. That's why we did not use the angle specific theta. We use the theta to be 90. So section of the wire, small section of the wire, it is perpendicular to a magnetic field. As a result, we use F is equals to BIL. Calculate the force acting on the coil. Calculate the force acting on a coil of 120 turns. So 120 times the coil is being rotated and the diameter of the coil is 4.5 centimeter. So the diameter of the coil is given 4.5 centimeter. And the strength of a magnetic field current is there, and 120 times it is turned around. So we need the force F is equals to BIL. Now length, what length we'll take? We have the diameter. So length is actually the circumference, because what length in a magnetic field, that will be the circumference. And what is the relation between the circumference and the diameter? So circumference is 2 pi r, or we can also say it is pi d. So the length will be equals to pi d, but I will multiply this by total 120. Why 120? Because the 120 times it is having the number of the turns. So I is the current, 0.11, and strength of a magnetic field is 0.8 Tesla. We'll get the value for F, but keep in mind the diameter is given in centimeters, so 0.045 meters will be there. So length of a wire in a magnetic field times the current which is passing through times the strength of a magnetic field. We'll know how much force this wire will experience. So it is only 1.5 Newton as a force this wire will experience. In part B, an amplifier unit can be used to amplify the music from a device with a small speaker. So maybe you have seen like we have like speakers are there, even a wireless speakers are there. They can amplify the sound. So amplifier unit can be used to amplify the music from a device with a small speaker. Like if anything is there, we want to play in a mobile, the mobile speaker is very small in size, so it cannot produce a high intensity sound. So we can amplify the sound by connecting a speaker. So if the amplifier unit, there is a coil connected to an amplifier and a loudspeaker, as you can see here. A smartphone is placed on amplifier unit. So we place a smartphone here, and this is the coil in the smartphone. Above the coil of an amplifier unit, this is called mutual induction, because what will happen? Explain how the music played by a smartphone is also played through the loudspeaker in amplifier unit. So first, what will happen? There's a current in the smartphone, and that current is producing a magnetic field. And these magnetic field lines are passing through. These magnetic field lines are also passing through the coil in the amplifier unit. So what will happen when the magnetic field of the coil in a smartphone changes, when the current in the smartphone changes, the magnetic field will also change. And due to change in magnetic field, that induces EMF. And when the circuit is closed, that produces a current, and that current is amplified, which fed into a loudspeaker that will produce the sound. So that's how this amplifier unit working. So what will happen? There will be a variable current in the smartphone coil which produce a variable magnetic field, and that magnetic field therefore there will be a change in magnetic field or magnetic flux linkage for the amplifier coil, and because of amplifier coil there is a change in magnetic flux linkage, so it induces EMF. And as a circuit is complete, that produces a current which is then fed into a loudspeaker, which convert the electrical energy to sound energy and produces a louder sound. So this is the same working principle as we discuss about the working of a transformer, how transformer work. Same way this amplifier unit is working. Is it clear, this one? Same way you have seen like cordless charger also use the same concept. I can also convert this device into a cordless charger. So what happened in a cordless charger? Like we don't connect any wire. We just place a smartphone on the panel and the smartphone get charged. So how the smartphone get charged? Because there's a AC input which produce a variable magnetic field, and the changing magnetic field produce a current in the smartphone coil, which is transferred that and store that into a chemical, turned electrical energy to a chemical energy. So same way the wireless chargers are working.